Cardiovascular disease remains a global health challenge, responsible for around a quarter of all deaths, affecting more than 7 million people and costing the NHS approximately 7.4 million, excuse me, and costing the NHS approximately 7.4 billion per year. As healthcare systems strive to manage, diagnose, and treat, early intervention becomes increasingly critical. Joining me today is Stuart Long, CEO of InfoBionic.Ai, to discuss the issues and how his company provides solutions for monitoring, diagnosing, and managing cardiac patients remotely. Stuart, thanks for joining me today. How does cardiovascular disease impact public health, and why is early intervention so critical?
Sure. Yeah, I think some of the statistics that you mentioned are the direct impact of cardiovascular disease going unchecked. It's been a growing concern. In the UK, it's roughly 30% of the population. In the US, it's half the population, with a big chunk of that population in the more advanced stages of cardiovascular disease. And one of the challenges of cardiovascular disease, if left unchecked, it will move outward from your heart. It'll start to affect your lungs. It'll start to affect your circulation. It can, you could get diabetes and high blood pressure. And so those are the complications that if you leave cardiovascular disease unchecked. So the early intervention or the early identification is paramount. When you cited the costs, they're staggering. And it's really because there's certainly kind of root causes that, hereditary lifestyle choices, certainly location, geography certainly plays a role in cardiovascular health. So the idea that we can make technology available globally at a low cost that can communicate in near real time the appropriate information about patients early enough so that clinicians can make decisions sooner so that they can stop the disease or prevent it or treat it more effectively so that it doesn't escalate, that has two great outcomes. It improves the quality of life for the patients, and it will lower the costs. And I think that's the driving force for companies like ours, and it's certainly the driving force for physicians worldwide.
So, what barriers exist then in traditional cardiac monitoring that limit accessibility and continuity of care?
So I think the limitations have been, we've only been able to really address them effectively, really in just the last, less than a decade or so. And that's just because of the infrastructure that's in place today with the new cellular networks and cloud infrastructures and things like that. But devices historically going back to the 60s were worn and they didn't communicate. It took more time to interpret the data than it took for you to wear and collect data. They initially only used to get about a day's worth of information. Today, that you can monitor for up to 30 days. You can go longer if you want. You can implant one in your body and go up to 3 years. It's changed quite dramatically. But the barriers, I think, still today is that many of the devices don't communicate what's important about the patient that is accurate enough for the doctors to make the right decision the first time. So that they can get the intervention or the treatment right sooner than later. And so I think we've just been, just in the last decade, that's what we've seen is we've been able to move that needle. We've been able to do those things. So we know it's possible. We're seeing more and more companies come to market like that. But the barrier has been accessibility of the data getting off the human body fast enough to get to a clinician, but then presented in such a way that the doctors trust it enough to make the right decision. Was it enough information to prescribe medicine or send you to the hospital? And those are the kinds of differences that can be made. And oftentimes lacking information will cause you to choose potentially one of the wrong paths. And you don't know it until it's after the fact.
Yeah, sure. In what ways does your product or your company's product provide a comprehensive approach to remote cardiac monitoring?
Sure. So our job is to diagnose what is the electrical problem with your heart. So your heart has two sides, electrical and plumbing. And the electrical side is the part that causes the heart to actually contract and beat. And the plumbing is the result of the heart beating. It's pushing the blood through. So our job is, if there's something wrong with the wiring, we want to put a monitor on and try to figure out what that is so that the doctor can look at that with enough confidence to say, I can see exactly what that is. This is the exact treatment that I need to do, with enough quality. And how we're different is, it's very difficult to do this in a remote world because people are moving all the time, lots of noise because the wires are jiggling and things of this nature. So we're experts in signal processing, getting that data off in a noisy environment, applying different algorithms that we've used machine learning, which is a form of artificial intelligence, to train to reduce the false positives, sift through the noise, really. We've created some technology like noise canceling headphones that allow us to look at noise, and even though it might look like an arrhythmia, it's actually just a normal heartbeat. So we're able to do that and then stream that information in near real time back to the clinician so they can see that. And if it's urgent enough, we'll give them a call so that they can intervene. But they can trust the data when they get it, as if they got it in the hospital. That's what, as if you were in the hospital getting that test, so they can make that right call, whether it's medication or, invasive intervention.
And so it sounds like this system has a lot of benefits for the clinician rather than sort of wait for the download of data that he's seen it in real time.
It still surprises me that there are devices in market today in the US that are wildly popular that don't communicate. By the time you put it on, you mail it out, wear it for 2 weeks, mail it back, the lab assesses it and gets your report. A month has gone by. And you could have had a major catastrophic event in the meantime. So I think in the next 5 years, the demand by patients will be that it's always on communicating. We're already starting to see that. But the idea that we can provide a very high level of quality, that's what we're known for in terms of the signal processing of that in a noisy world in terms of movement and patient. Is where we really separate ourselves, and that causes a physician to trust the data, which increases adoption, and that allows them to use the system, which gets to earlier intervention for the patient, which leads to better outcomes for the patient, better quality of life.
Yeah. So I think the question I have is, why didn't somebody else think of this earlier? Because it seems listening to you, it seems like an obvious solution. So I admire that you've stepped forward and stepped into that space.
Yeah, it's I think people were trying to solve it for a while. The challenge was the amount of information that gets communicated, right? So your heart beats about 100,000 times a day. If you've got an arrhythmia, and it could beat 200,000 times a day, and if you wear that monitor for 10 days, you can easily do the math. That's millions of heartbeats already. Sometimes you wear that for up to 30 days. So that's a lot of information to communicate. So communicating all of that information, organizing it, and then putting it in front of the physician so that they have all that information too, but it's not overwhelming. They're able to assess that and get to the heart of the matter, pun intended, very, very quickly, has been really the secret sauce. So people have been trying to communicate data, but to do it, they would only send little snippets. So you wouldn't know if it was a problem. You wouldn't know when it started or when it finished, how long it was, how much time were you in that during the monitoring period. Those are all key elements. And in today's world, you can't really buy a new cardiac monitor that doesn't do these things, even despite some of those that still don't communicate. So I think we're fast approaching the world where always on is key, because consumers just expect it.
Yeah. Yeah, sure. Well, thanks for joining me today. But if we want to learn more, where could we go to learn more about your product and the system?
Great place to do that is our website. It's InfoBionic.Ai, and you can look under our news and events section. There's lots of great published data there.
Well, Stuart, thanks very much. It was very interesting listening to you talking about the product, and I wish you well.
Thanks for having me on. I appreciate it.